All right. About this guy. Once again, burying the lead. I say, tell me something cool about yourself. Nothing. Oh, no. Then he drops on me. He's got a YouTube channel. Well, he's going to start his YouTube channel, right?
Yep.
And it's on weightlifting and bench pressing. If you can't go 350, don't talk to me. I believe that's what it's called. That's the one that's right. That's what it said? Yeah. If you can't go over 350, why are you even in my face? Do you even lift? Don't skip leg day. That's a long title. That's all right. No, actually, it's about Go. Is that a language? Go. Yes, he'll be starting on that, so make sure you keep on the lookout for that. But the real thing, he just got married in Vegas.
It wasn't just, but
Just is
it was
fine.
back in 2016, but yes.
That was all right, man.
Yeah.
Got married in Vegas, and you said y'all went to the Aria?
It was at the Aria, and we got a bus and took everybody to the, who showed up to the Pinball Hall of Fame, which is a great place there.
Did y'all, when this dude walked in, did y'all think Mac Daddy and a Mac? Did y'all think this dude a Mac Daddy? And how many people can say they got married in Vegas? Put your hand down. No, that's not what we're talking about. No, absolutely not. Absolutely not. But this gentleman is going to tell y'all all kind of cool things. Hopefully there's a cool Vegas picture up there. We don't know. Please make a whole lot of noise for Mr. Brian Chirgwin.
So tour Go and why you should learn it, or why become a gopher. Go was released in 2009. Robert Gersimer, Rob Pike, and Ken Thompson. The goals were for fast compilation, minimal syntax, maximum clarity, static binaries, no DLLL, built-in concurrency, explicitness over magic, and the standard library, which is quite extensive. Companies using Go and products. TypeScript was just recently moved to Go, still in development, but they're getting a 10x performance increase. And most of these products I do use. Uses backend, of course. Tools like Docker and Kubernetes, CLIs. You can do games and apps. Not a game like Halo, but you can do smaller games. My name is Brian Chirgwin. I have 40 years of development experience. My wife and I recently moved to Clovis, New Mexico with our dog named Roulette because she's a black Dachshund and red heeler. Of course, we got married in Vegas. I used to run a meetup in Norman, Oklahoma, but this is my first conference talk. Thank you. Go is more than the compiler. Documentation is important. There is a way to do documentation. It's kind of like JSDoc. And if I flip to, oops. If I escape out of that and go over here, this is some of the docs that I have. I want to show there's an example here. And in the code, switch to the right one. The example is actually part of your documentation of how you use your API. And I have the output line here in a comment. The test will test this. If you break this, you know you have a breaking change. Code formatting. There's a standard Go FMT function. My editor does it, my IDE. The top one is the way it's formatted. The bottom way will be changed to the top. So there's no fighting over how to format code because there is a standard. Clear syntax, any packages you import or variables that you're not using, you need to take out. If you leave them there, it will complain. This keeps your code clean, so 6 months later when you look at it saying, why is this here? What's going on? Testing. You write test in Go code. No libraries. There are libraries available if you want to use them, but you don't have to. You can just use Go code. Dependency management on your dependencies, what you import. Packages, how to package up code into a library to be able to be used in multiple applications. Versioning is built in so you can version your build. Go takes its roots from C and C++. The story I've read is that the three were compiling some C code, C++ code, and it was taking 40, 45 minutes, so they came up with Go during those times as an idea. They removed classes, so you don't have a inheritance, you don't have an inheritance tree, you have to grok, you don't have constructors and deconstructors, you don't have exceptions, no macros, operator overloading or function parameter defaults, no undefined keyword. You have to be explicit. So you have to type down the bottom here, you have to actually convert your types if you want to compare them explicitly. This makes it easy. 6 months later, when you read the code, you know what the developer was doing. You don't have to guess or depend on the magic of the language to do it for you. And then have to rethink what the developer was thinking. No type coercion. You need to automatically type. Now, I know these don't work the same way, but because I did it backwards, but in JavaScript, 1, 2, 3, 4, 5, 6 would become a string. Here I'm converting it to a number from ASCII to integer. Oops. And checking if there was an error during the conversion, I can do something, and then I can add them together. Reserved words. There aren't that many of them. You take concurrency out, and the two I have in red, which I haven't used, you're down to 20. The identifiers and your types and constants, and then the core functions in the library, in the core language. Everything else comes from the standard library, which a standard library is visible. You can read it. I recommend reading some of the later stuff. Talk about performance. In the chip, you have the L1, L2, and L3 cache. Those are much faster than RAM. So if you can get your data into the cache, you can quickly go through it. An array, of course, contiguous memory. Size set up compile time. A slice is a window into that memory. And then you have a map, which is a hash map or a dictionary, which is an array of hashes. Those are the three data types you have in Go. There's no linked list because a linked list requires a pointer to go back to RAM for every entry. If you're going over 1 million entries, that's going to take forever in comparison to the chip. Variable declaration. Once you var int, ints become 0. They have a 0 value. Strings are an empty string, and so on. They cannot be nil. There's a shorthand format in functions where you can do the colon equals, and it will automatically make, at compile time, decide what the type is based on its assignment. This is an example of the lack of complexity, the simpleness of Go. If you look on the left side, I have many of the ways, not all, that you can do from JavaScript. Mostly, I believe I pulled them from there. ways of doing iteration. There's a lot of them. You add promises to the mix, and it changes the way they work. You have to remember when to use what, if you're doing an object or not an object, etc. In Go, there's a for loop. That's all you got. For loop to iterate. Then when you're iterating, you can look at, what am I doing? The bottom one is an index and value of a slice. Pointers store the value, the memory address of another variable, and it can be nil. It is the only thing that can be nil. Well, that and interfaces. Ampersand to get the address of, asterisk to dereference. You have to pass by reference if you want to modify the data. If you pass by value, the data will not be modified. It will still be, this one will still be 42. This one will actually modify it and be 45. This is true even if you're passing in a slice of 1,000,000 items. It will make a copy. So you also want to use a pointer if your data set is large. A slice is a window into an array, as I said. And multiple slices can refer to the same array. So I'm going to go through some code here to kind of show this. And as I mentioned, Go comes from C, which is closer to the metal, so to speak. It's closer to what you're working on, closer to the hardware. So you kind of have to know how things work. They don't want to hide that from you. They don't want to make it magic and have it disappear so you don't have to worry about it. This allows you to gain speed because you can build what you want with speed. So here I created an array. Then I create 3 slices. The S1 from 1 to 3 takes 1 to 3, not including 3. But the capacity is 3 because it goes to the end of the array. S2 is from 2 to the end, and S3 is the whole thing. So I have 3 slices referring to the same array. When I append to S3, there's no room in the array. Its capacity is full, so it makes a new array. It actually sets the capacity to double, at least up until a certain point. And then it copies over the values and then adds the new value. S2, I change Jack Torrance. Well, I'm changing S1 and A as well. When I append Chucky, since the capacity was there, it just adds the capacity, but I change S2 and A as well. And when I create a new array of appending part of S3 and part of S3 again, which creates a new array, the old array will be garbage collected at some point in a few milliseconds. Type aliases and definitions. Equal sign means they're equal and equivalent. You can actually do a comparison. Without the equal sign, you're creating a new type. Yes, you're basing it on another type, but it's a new type. This allows you to define a product ID and a user ID, and you can't swap them by mistake. Concrete type. Composite set of fields, properties. But you can have a receiver method. And that receiver method is a method on that type, and it's a struct. There are no classes to grok. There's no hierarchy to understand. Abstract types are the power of Go. They're the interfaces, the contract of methods that you need to provide to meet that interface. But they're implicit. You don't have to use the implement keyword. If you implement those methods, you are that thing. It's a form of duck typing. From the standard IO library, there's the reader, writer, and the reader, read, writer. The reader has one function read and the writer has one function write. These are used, file IO, HTTP requests, they're used throughout the standard library. There isn't any type, try not to use it. It is actually an interface with no contract, with no methods. When you create a package, anything that's lowercase is automatically private. Anything with an uppercase is automatically exported. There's no protected keyword, private, public. There is no central repository for Go code. There is a place to put the documentation, but not the Go code. You've just put a URL to your GitHub or wherever you're writing the code. Demo. How am I doing on time? Wrong one. Here's an example of a interface. I have an aliver interface. Usually when you have one method in a interface, you end it with ER. So I have an isAlive function. I have a human structure. I add a function to it. This is a struct that has no properties, fields to it, but it has an isAlive function that I wrote that takes the receiver function of the human. So I can call this function when I create a human, and I'll show you that in a second. Returns true, zombie isAlive returns false, ghost. I have a cat that's random, depending on a random number. A mummy if it's alive. And the aliver report takes an aliver. It actually takes a variadic set, so any number of them, and I'll range over them. And I'm using reflect to get the type of it, and then the if it's alive or not. So I created the different types, call the aliver report, and that is, do I have it down here? I don't. Make, I forget what example that is. Where is this used? Oh, it's main, so I go here. It's 12. Interfaces, so when I run it, it tells you what it is, and if it's true or false. The cat came out true that time, and it may change if I run it. Yeah, it came out false the second time. So the app I'm running, and yes, I am running the app here. Escape and go to my to-do list. So I have a page called the Hello World, the simple page, and I'm using a package called Temple, T-E-M-P-L-E, and that is well, first let's go through the main. When I load the program, I'll start with main because main is the main package. It's where you enter your program. When you enter your program, it calls func main first. I load a configuration, and in the configuration, I load from command line options, then environment, and then a default. And these compare.or will take the first one that's not the 0 value of that type. So I can override with a flag from the environment. Then I am starting the server, creating a new server and starting it. And in the server, creates the server, and I create I register the routes. This looks a lot like Express, at least to me, where I create a new router, server mux, multiplexer, and for example, this is the one that I'm showing is the HW page, and I have a function that handles that. Well, this function actually loads the hello world component and renders it, and that component is right here. This is a temple component. You use temple.generate, and it'll generate this to Go code. The page is another component, which I have open right here. And the page has my header, my body, and a children, which is what is being passed in to the page. This is a lot like JSX server-side rendering in React, except it creates Go code. So if I come in here and I take away these, I'm also using something called error. Once I save that, it will recompile and reload the page. So 2 of these will disappear. There they go. So I have the same React development environment. And to do template, I'm also using something called HTMX. HTMX is a library that adds missing HTML features. So I have a feature here of on an input, I can add an HX post. I can also do HX delete or other commands. I'm calling to do with the ID along with completed, so I can check it to be completed. It actually toggles. I didn't rename it. And from there, it will reload because I have it to say on change. And then when it goes to the server, the completed sends a HTML partial back that targets this item, the ID, to do in the dash ID, and it swaps it out. So I get the new one in there. So when I come in to my page on the root, if I uncheck this, it actually puts it back in that spot. It's actually making a round trip and updating the server. Back to the slides. There are a lot of resources with Go. These are some of them. I recommend going through the tour of Go. Golang.org is and the Go by example is as good as well. There's a reason Douglas Crawford wrote the JavaScript, the good parts. There's a lot to JavaScript and a lot of magic going on. Cut down what you're using and you can make your code easier. And I think by learning Go, it can help you understand some of the simplicity you can get to. Kent Beck said, make it work, make it right, and then make it fast. And Go code kind of lends the ability to refactor code quite easily. Thanks for listening. And here's how to reach me.